Hey, everybody.
Hi.
Good to see you back.
Hey.
I just realized before class I hadn't put that test out there for the last module, so I'll get on that. Sorry about that. My to-do list gets a little mixed up sometimes. Let's see. But it will happen. Some of you may not have looked yet, which is good. But I know some people have. You got some studious students. So I thought I might as well confess because I wasn't going to get away with it. Let's see. I did. Let me see. Let's look at your view. Here's the student view. Okay, there's Eleanor.
Mr. Ritchie,
Yes.
so I'm almost at my house. I joined from my phone. So
Okay.
is it okay if I leave in a couple minutes and I'm going to get on my laptop and join again?
Sure, that'd be fine.
Okay, I just wanted you to keep an eye out for me because I know I'm not going to say that you don't pay attention, but you just might not notice me trying to come back in.
Sometimes I don't pay as much attention as I should, but I'll ramble for a while, so you probably won't even miss anything.
Okay,
Sorry.
just a couple
We'll see
minutes.
you soon.
All right.
Bye. All right, that was the last module, binomial probability, and there's no test there yet. Oops. I was getting all the other stuff for the next module already, and then I noticed that. So I'll get that fixed. But here is the module 5, normal probability distributions or normal curves. Sometimes it's called. It's going to be just a little bit different in this module because I think I like the question structure better. There's not going to be like a homework assignment. There's going to be a review, and it's a PDF. We did this in one of the other modules. We worked through a PDF so instead of a Canvas assignment. That's a little less convenient, but the review is better, I think. So we'll just have a review, and then we'll have the test. And every question on the test will be a similar question will be on the review. So we shouldn't have to worry about that. And not that happened very often. And there are these test review videos, and I think those are recordings. Oh, I know it is. These are recordings of all the test review questions, probably from a previous semester. But we're going to go over them again anyway and label them Zoom, and I'll post those. So you'll have the updated version, even though you don't really need it. What else do we have in here? All right, there's a table in here, which we were going to use regardless. So I'm not adding something different. A normal distribution table was going to happen anyway. So that's this very first thing in the module. Then there's just some videos from Khan Academy type videos, if you like this sort of thing. And then, like I said, test review videos. And then I'll post the Zoom ones like I did before. So not a lot different, but a little bit different in that we'll have this test review PDF. Let's see. Now I am going to talk about the material first before we jump right in and do review questions. Let's see, new share, whiteboard. Oh, I need to, probably would help to get out of the student share or the student view. Here we go. Leave student review. View. There we go. I don't know if that made a difference or not, but there we go. These are sometimes called, these are normal. Normal curves or normal distributions, sometimes called bell-shaped curves. And they can be used for a variety of things, including probability. And they look like, they call them bell shapes sometimes. Maybe I should write that down here. And you'll see why they're called bell. Because they look like a bell in an old sense, like Liberty Bell kind of bell. You know, they look something like that, where there's, if you can imagine piling people up, one of the good ones is to look at is like height in the US. I got to center my line, make me feel better. There we go. Let's see. Let's do this the right way. I don't often do that, do I? The average height of a female in the United States. That sounds interesting, doesn't it? Let's see. Mean height and standard deviation. I don't know. What do you think the average height is of an adult woman in this country?
Like
Just from
5'6", or like
Yeah.
5'4".
I think I have a feeling that you're right about right. I was going to guess like 5'5", somewhere
Yeah.
around. Mean height and
Sorry, I
standard.
didn't know what you were saying before that, but
That's exactly what I was saying. You got back online just in time to answer the question. Mean height and standard deviation for US female. Now, how do I press enter here? I'm hopeless sometimes. All right, Brent, how do you search? Maybe that'll do it. Here we go. All righty. They do it in just inches, but here's the inches. And we're just going to assume that this is accurate. There's probably a million studies and they are all probably a little bit different. So 63, oh, so it's a little shorter than we thought, Anna, just a little bit. 63.5 inches. That would be 5'3.5".
that is not average.
Well, you know,
Not at all.
that brings up a really good point. And it's really, we get influenced often by the crowd we run with. If your group of friends are taller, like if you hang out with a bunch of, say, athletes, in general, athletes are taller. And if you've always hung out with a bunch of athletes, or if you're an athlete, you might feel short in comparison to that little group, that small group. And so we can get influenced a lot by who we hang out with. Maybe the theater kids aren't as tall. I don't know. But this is saying, well, let's see. Let's look at some other ones just to make sure we're not way off here. Okay, this one says 5'4", ages over 20, or standard deviation over 20. That's a little easier to remember. Can I cheat and start using that? And 2.5, that's 2.2. I don't like that. Look, I'm trying to find numbers that fit me instead of using just the real numbers. And then they say, what's the most attractive height for a woman? That stuff happens. You know, you hear that in the last several years. I've started to see more about that, even in the way of memes about guys and their height. And women prefer guys at a certain height, or a little taller than this height or that height. So that's interesting to think about that too. Why do we think that way? So I'm going to say, after all this, hey, Alex, are you there?
Yes, sir.
How tall are you? I know you're tall.
5'8", I would say.
You're only 5'8"?
Maybe. I'm not really
Okay.
sure. I'm not really sure.
I know at one point, I've just known Alex from watching him play ball a lot. And at one point he went through this growth spurt and he was taller than everybody else. But that's how people are. We don't all grow the same rates. You can see how ignorant I am of it. I thought he was 6 feet tall. So 64 inches, we'll say, is the average, and 2.5 standard deviation. All right. Mean height. And then standard deviation for height. For females. So 64 inches is 5'4". That might sound a little low. Plus, you can also live geographically, and this is in the whole US, because geographically, you could live in an area where the mean heights are higher. In certain parts of the country, the mean heights are definitely shorter. And that leads into all kinds of interesting discussion topics about human biology. And you know, when people settled in the United States, why some people are smaller, and whether height was advantageous or not. Sometimes it was better off being taller, and sometimes it was better off being shorter. My mom is from Pennsylvania, like up towards the Northeast, in coal mining country. And up in coal mining country is a lot of Germans. They immigrated over from Germany in that area, and they were all coal miners. Now, if you're working, suppose you're a man and you grew up, everybody grew up working in the coal mines, do you think it would be to your advantage to be really tall or short? If you're working in the coal mines, would you rather be 5'6" or 6'6"?
Short.
Yeah. So that's why it leads to interesting discussions, because then short men then had an advantage over the tall men when it came to mining, because they don't want to dig mines any higher than they have to. You know, they don't want to get in there and dig and have to dig mines that are 7 feet in height. just so these tall guys can get to don't have to bend over all day. They want to dig them short. So a man who is shorter has an advantage, is going to be more successful, most likely more successful than a man who's taller. And so it's just a biological fact. Then more successful men have what they call more breeding opportunities. I know that sounds a little crass, but they do. They're more successful in life. Typically have more of the kids. You know, they marry more often, have more of the children, pass on that trait to their children. So the groups up in Pennsylvania, then as a group, tend to be shorter. And then in some areas of the country, being tall, in some areas of the world, really, being tall or fast or whatever, those things are more advantageous. So you see populations that are taller. And my mom's dad was probably 5'3". He was tiny.
Wow.
Yeah, by our standards, you know, by Southside Virginia standards, that is tiny. And Ayanna knows my wife, and she's not short at all. She's from a different area, not coal mining country, and she's like 5'9" or 5'10".
Yeah, I would say she's kind of tall. She's like, because I remember, because I'm kind of tall. I'm like 5'7", but I remember
Yeah.
she was taller than me, and I seem kind of tall. So
I know, and you notice that right away because it's different than you're used to.
yeah,
You're used to being tall if you're around a group of girls, but then when a 5'10" girl walks in, you notice that because that's unusual for who you're used to hanging out. But I remember going to that side of the family, my mom's side of the family. One of my cousins was getting married, and the reception was just in this big room, and everybody was milling around. It was like finger food kind of thing, where everybody was standing and kind of milling around. You know, like 100 or 150 people there, and it was from mom's side of the family. And I could stand on one end of the room and see my wife all the way on the other end of the room, because it was like her head was floating around because everybody in that room was short, except for precious few people. And I always tease my wife about it because I could just see her head bobbing along through the crowd among all my cousins and stuff who were 5'4" and 5'2". You know, it's not unusual to have the really short cousins and stuff over there. Now, my dad's side is taller, and they were cotton sharecroppers. So I'm not really sure. Of course, the fact that they were sharecroppers meant they moved around a lot, because I'm not sure you would have a lot of advantage being taller and picking cotton, because it grows pretty close to the ground. But anyway, I got way off topic as usual. This is our female average height and our male average height. And then we know what a standard deviation is, right? That is where that's the average, basically the average distance from one person to the next. Each standard deviation for a female is 2.5 inches. So we could talk about, let me go back to my picture. If your mean height, I think I'm on the right thing, is 60, I'm just going to talk about it in inches. 64 inches here. That's the average. And every standard deviation was 2.5 inches away from that. If you were one standard deviation above the mean, if you were a little taller than average, you were one standard deviation above the mean, and every standard deviation was 64 inches, how tall would you be? Somebody's thinking it. Every standard deviation is 2.5 inches. So if you're one standard deviation above the mean, how tall would you be?
Okay, is the question that simple or am I like over?
It's that simple. I know somebody's thinking. They just don't want to say it
128.
because that's twice. That's double.
Oh,
That's double the mean.
60, it's 66.5.
Yeah, we're not doubling the mean. We're adding, but that's the right idea. But we're adding the standard deviation. And remember, the standard deviation is if we took everybody, say Ayana's in our math class, she's the average height, just say, and say she's 5'7", and we added up all the heights of the people in our math class and decided the average distance we are from Ayana is 2.5 inches. So we check all of our heights and we say on average, we are about 2.5 inches different than Ayana. We're either above 5'7" or below 5'7" on average. So that's all the standard deviation means here. So every time we go up one, we go up 2.5. What would 2 standard deviations above the mean be? Now we got to add decimals. No one wants to do that. But I can wait. So we're going from 66.5 up one,
to
up a,
69.
there you go. Very good. So if I'm 2 standard deviations taller than average, then I'm 69 inches tall, 5'9". What about the next one? Then I'll go the other direction.
$71.5.
Thank you. So, and now these numbers, I know I've made up a lot of numbers in this class, but these are the numbers from the web that we were looking at, which were average heights for female in the United States. So they're fairly accurate. And so this is 1 standard deviation, 66.5. That would be 5 feet, 6.5 inches. So if you're 5 feet, 6.5 inches tall, you are 1 standard deviation above the average height. If you are, then this one is 5 feet. 9 inches. And that is 2 standard deviations. And finally over here, we're at 5'11.5". That's getting pretty tall then for a female. I think you start to notice that and say, yeah, that girl's kind of tall. Five feet, 11.5 inches. Now, what about the other side of the mean? If we're going below the mean, 2.5 inches below the mean, how tall are you?
61.5.
Hey, very good. Sometimes I just need to be quiet and listen because you guys are trying to answer questions and I'm talking over you. So 61.5, that's pretty short, isn't it? 5 feet. Well, I don't mean to insult anybody here. 1.5 inches. And on down. But because the mean is 64 inches, if a distribution is what is a normal distribution, that means that when we gather up all the data, most of it is piled up in the center. Most of us live right near the mean. And if we do, then we call that a normal distribution. And that doesn't apply to everything, but it applies to a lot of things. It applies to a lot of things that happen in nature. It applies to our height. It applies to are for men for neck size. You know, I don't think women are, I don't know if women are very conscious about neck size or not, but with guys, a lot of dress shirts are sold based on, one of the things that they're based on is your neck size. So you go shopping by your size of your neck. And so when you go to a department store, if you're a buyer for a department store, they're going to order more shirts where more that people will actually buy. And so if the average height or the average neck size is 16 inches, they're going to have more 16-inch neck size shirts on the shelf than anything else. Or else you have a bunch of leftovers laying there. So anyway, if it's a normal distribution and the data is normally distributed, then this is the data all piled up here under this bell curve. And this is our mean. And we said that that was 64 inches. So they piled up this, and since it's normally distributed, most people are around the mean. So therefore you get this big bulge. You know, most of the people live right in here. Here's all these people. These are women, by the way. But we can draw them however we want to draw them. And then by the time we go out this way, the very tall people, there's fewer and fewer people piled up. So you notice that when you're out, if you see a woman walk in and she's 6'6", then that catches your attention. And it catches your attention because there's not a lot of them. They're very different than we are. And I'm not saying good or bad, I'm just saying different. So they're very different, and therefore they catch your attention. And if they're 4'8", the same thing happens. They're very unusual. And so they typically catch our attention because there's fewer of them. And we can actually draw the lines as we come down here. Let me get rid of some of my people here. And we're just talking about this today. We'll apply math to this later. All right, here's one standard deviation. So these people are, now this is on the plus side. Oops, where did that come from? What was it? 1 over 66.5. Then we had, I went all the way to 3 over. And on this side, we went to 3 under. That was 66.5. These were 69. These were 71.5. And then when we went below the mean, we went down to 61.5. And what's 2.5 inches below that? 59. Did I do that right? Yeah, I believe I did. And this is 56.5. So 61.5, that would be 1.5. So if we wanted to know how many people or how many females are 2 standard deviations or below the mean, it would be all the people that fill. Get another color here. Here's 69. So all the people that fill up this space would be the ones that are all the females compared to other females. All these females are 69 inches or lower. That represent, the whole curve represents the population of all females. And then the blue area that part of that 100%, that's the percentage of women who are 69 inches or shorter. Does that make any sense at all? A little bit.
Yes.
But thank you. Thank you for playing along. Sometimes I wonder if I'm not talking in circles. So we can talk about it as a percent of the whole. You could ask, well, what percent of the women are, 66, one standard deviation? Let me erase here.
Can I ask you a question?
Yes, please do.
Okay, I understand everything, but where did we get the 2.5 from?
We got that off the internet and it told us that that was the standard deviation.
Oh, okay, so we just looked that up.
Yeah. And we saw, and there was a couple of different ones there. So I don't know how accurate that data is, but we're just pretending it is. Yeah, we just got that off the web, off the same place that told us it was 64 inches for the mean. It also told us that it was 2.5 for the standard deviations. I'm with Ayana. I think it's maybe a little low. I've heard the 2.5 before, but the 64 feels a little low. But I also think that maybe girls in our area are typically a little taller for whatever reason. They're taller than most. So that's where that came from. Let me repair my curve here. I don't know if that was worth it or not. So if we wanted the ones that were just one standard deviation above the mean or shorter, that we would add the mean is 64 inches. So we add one standard deviation to that, which is 2.5. And that's where that comes from. So 66.5, this is one standard deviation above the mean. And that's represented by that graph. And, I'm kind of glad now that in the practice test we did for the last module, it asked us to draw a histogram. And the histogram represents discrete data instead of continuous data. And so you can really see the difference when you look at a histogram as compared to this normal curve, because a histogram looks all blocky because discrete data, we don't count the numbers in between. We say there's 3 students in my class, there's 5 students in my class. We don't talk about 3.5 students or 5.5 students or anything like that. So when you graph discrete data, instead of getting a nice smooth curve, you get, let me see if I can draw it. You get kind of a blocky shaped graph. And it may not be perfect. You may get a histogram that looks like that, but you can kind of see how that resembles, in some ways, a smooth curve. But when it's discrete, it forces it to be blocky because it's discrete data, 1, 2, 3, 4, 5, 6, like that. We don't have 66.5 or 66. We don't have data that you measure. We have data that you count. So you get this histogram instead of these smooth curves. So they fit. Which one you use really depends on the type of data that you have. Now, if you are some of these have been, the arithmetic hasn't been too bad. Okay. So let's do another color here. Okay. We're talking about female heights again. The mean is 64.5. Just the number we grabbed off the internet. And the standard deviation is 2.5 inches. If you are, let's see, I'm gonna pick on the, Anna told me her height. Anna, is it 2 N's in your name, Anna?
Yes, sir.
Thank you. Okay, Anna told us she's 5'7", which is in inches, she's 67 inches tall. How many standard deviations above the mean is she? What was that? I think somebody tried to answer, but they're buffering, so their audio is not coming through.
This is Annabelle, South Boston. I'm going to leave the meeting because there's nobody here.
Okay,
All
thank
right.
you. All right, there's our question. The average female in the country is 64.5 inches. Every standard deviation from that is 2.5 inches. Anna's 67 inches tall. How many standard deviations of the above the mean is she? I'll give you a minute because I know somebody knows it already and you're just not ready to say it yet. So every little step you take, every standard deviation is 2.5 inches. So every time you take a step that's a standard deviation long, you go 2.5 inches. Any guesses? Well, just think about it.
Ooh,
Kind of
sorry.
turn- Oh, go ahead. Go ahead.
Is it just 3?
No. Well, you're almost, it's almost 3. Well, you're almost 3 inches above that. But how many standard deviations is that? It's like if every time you took a,
2.5 or something.
well,
Like
you're,
1.5, but less than a half.
Let me recount. Hold on.
well, think about it when we did it. You're both thinking the correct way. First of all, we're starting at 64. That's here. And we want to hop up here to where, no, we're starting at 64.5. I messed up on that number, didn't I? But anyway, if you start at 64
Oh,
and we want to get up here to 67, each step I take is 2.5. How many steps did I take?
1.
1. Very good.
No, because earlier I was like, because when was it Jalen? She said like 1.5, and I was like, oh, that makes a lot more sense. But you said you didn't write the right number, so
Yeah, and she's correct. I wrote the wrong number. So can I adjust my numbers? Would I make it better or worse? Fix my own math. Let's say, I'm going to say, now I'm going to lie about Ayana's height. I'm going to say that the mean is 64, which it is, and that Ayana is 66.5. Sorry, I made you a little shorter.
it's okay. I honestly think I'm 5'6.5", but it's much easier for me to tell you 5'7" or
Thank
just
you.
one or the other.
Thanks for backing me up. It was
You're
my
welcome.
mistake. All right, so Ayana is 66.5 inches tall, and she's being very nice and playing along. And I wanted to know how many standard deviations above the mean that was. Well, if every step you take is 2.5 inches, and she's 2.5 inches above the mean, then that's what she just said. That's 64, excuse me, that's one standard deviation. Now, suppose she's 2 standard deviations above the mean. How tall is she? Well, let me do this. Let's say, suppose she is, I feel like I'm just butchering this today. Some days you just swing and miss the whole day. Let's
It's
see.
not as bad as you think.
All right. Well, good. I'm glad it's not, because I feel like I'm just off in left field somewhere. Okay. Suppose there's another person in this class, and I don't know who it is, but she is 59 inches tall. There's a female in our class. She's 59 inches tall. The average height is 64 inches. How many standard deviations below the mean is she?
Two.
Very good. Now, who answered that? Was that Jalen?
Mallory.
Mallory, sorry. Your voices are similar. Try to recognize. My eyes don't move quick enough to see whose little box lights up.
That's okay.
But this was, and how did you, now I got to really quiz you. How did you come up with that?
You just subtract 2.5 twice from the mean.
Right. Every step you took was 2.5 inches. So she went down 2.5 inches once, wasn't quite there, went down another 2.5 inches, and she landed right on 59. Now let me make it a little harder on you. What was going on? What a lot of students, a lot of y'all do a lot of math in your head and don't even think about it. You're doing all these mental calculations, and it just comes naturally. And you don't even think about the math you're actually doing, but you are. What formula? I need to erase some of this stuff here. Mallory said she just subtracted, you said you subtracted 2.5 twice. Is that what you said?
Yes.
Okay, that's how she did it. So what would be a formula for that? She took 64, she subtracted 2.5, and she got 61.5. She said, I'm trying to get to 59, so that's not close, I'm not there yet. So she took her 61.5 and she subtracted 2.5 again, and she got 59. I think you got a little lucky that it landed right on 59. And she said, I did the process twice, so that's 2 standard deviations. Now, how would I do that? How would I put that in a formula? Because it doesn't always land on a perfect number like that. What if I said that this person was 58 inches, where it didn't land on a nice even number? How many standard deviations is that? Well, I don't know, because I can't just keep subtracting 2.5 because it's not going to land on 58. So in her head, what did Mallory do? She didn't even think about it. And now that she is thinking about it, she's not sure how she did it. Just magic. But that's your brain using its reasoning skills. And like I said, a lot of times you don't even realize you have them. But it is. Now remember the notation. The mean is that Greek letter mu. And the sigma is the standard deviation. Because I'm trying to cobble together a formula here that's going to explain to us what Mallory did in her head. She started with the mean, 59, and then what did she do? She subtracted, well, I'll do you one better. She started with the number I gave her. So she said, Mr. Ritchie gave me some number X. I subtracted the mean from it. So I gave her 59. She subtracted, oh no, I got it backwards, sorry. See, there I go. Somebody was, she started with the mean. She subtracted the number I gave her. Oh my gosh, Brent. We're below the mean. That's what's throwing me off, not above it. So she started with the number I gave her, and she subtracted the mean from it. So I gave her 59. I said, how far below the standard deviation, below the mean is this person? And then she subtracted the mean from it, which is 64. And what do you get when you subtract 59 minus 64? What's 59 minus 64? I probably lost some of you all now because I kind of went
-5.
right. And it's negative because we're below the mean. If it was +5, that would be above the mean. You know, you can see that on a number line. Numbers that are smaller than the mean we're going to get a negative, and numbers that are larger, of course, will be positive. So Mallory got a -5. And we said, well, how many, if each standard deviation is 2.5, how do I find out how many -5 is? Well, then she divided by the standard deviation. So in her head, whether she wants to admit it or not, she did this. She said, well, at 59, that's how tall this girl is. The average is 64. And then I divide it by the standard deviation. And I get -5 divided by 2.5. And I get -2, which told her that's 2 standard deviations below the mean. So that's the little calculations going on in your head, believe it or not. And that works pretty good as long as it falls on an even number. You know, you can do that little number crunching in your head when they fall on even numbers and not a lot of decimals involved or anything like that. For example, if I said a female is 71.5 inches tall. How many standard, well, it's greater than the mean. I can see that because the mean's 64. But how many standard deviations above the mean is that? Well, I could plug it into my little formula here, or you could probably calculate it in your head. If I plug it in my formula here, I get 71.5. I subtract the mean from it. Then to see how many standard deviations that is, I divide by my standard deviation, which is 2.5. And what do I get?
Three.
Very good. Top is 7.5. The bottom is 2.5. If I do that calculation, I get 3. So if a woman is 71 and a half inches tall, which is, what is that, 5'11 and a half, 5'11 and a half, she is 3 standard deviations above the mean. So you say, well, if I can always just kind of figure it out, like Mallory just figured that first one out. She didn't even need the formula. She just told me, oh, that's 2 below. She said, why should I ever need a formula? Well, most things don't happen in nice, pretty whole numbers. You know, suppose the next woman that comes in is 68 inches tall. How many standard deviations above the mean is she? And here again, I know she's above the mean because the mean is 64. That's given to us. How many standard deviations above the mean is she? That's when you fall back on this formula. Like I could probably get close. I know that 2 standard deviations would be 5 inches. That would be 69.
It would
So-
be 1.6, I think, with the formula.
Yeah, and the formula is always better because that gives us the exact number. So she took this time, she fell back on the formula. No offense to your brain, but who wants to do all those decimals? It's divided by, so she plugged all those numbers in. Here's the number that I gave her. This is the woman walked in and she was 68 inches tall. This was our mean right here. This is our standard deviation. And it's always the number of standard deviations is not always a whole number. So she got 4 here. Am I right here, Mallory?
Yes.
Right so far. And that comes out to, give me a couple decimal places. 1 point.
I got 1.6 when I put it in my calculator. So that's all it
1.6.
gave.
Okay, just 1 decimal place. So
Mhm.
1.60. So whoever this is that's 68 inches tall, she's 1.6 standard deviations above the mean. So you don't always have to be it doesn't have to be 1 standard deviation, 2 standard deviations. It can be all the numbers in between those 2 things. That's why this is continuous data. You know, heights are measured, heights are not counted. So when we measure people, we can have numbers that fall in between. So you can be any number of standard deviations above or below the mean. And in this case, it was happened to be 1.6. And if you looked at it on okay, if you look at our graph here, our normal curve, and we know that female heights are normally distributed. So if we pile all the data up, we know right in the middle, most of us or most females are 64 inches. And if we went down 1 standard deviation, 2 standard deviations, or went up, these people are 66.5, and these are 69. And then the person that we're talking about falls, the 68 inches falls right about here. this person or this female is 68 inches tall. So we would say this percentage, if you will, of all the females are as tall as she is or shorter, less than or equal to. And then in next class, I think I'll bring some better examples and we'll see how to convert that to a percentage, because then the next question might be, what percentage of the females are shorter than this girl? This girl is 68 inches tall. I can see it graphically. The red represents all the females that are shorter than her. But what percent, what percent of the whole is that? And so we'll do that next. Like I said, I'll do a little better job with my example to explain all that out again. Because I don't think I did great today. But anyway, so things to do, my to-do list before Monday is I'll get that test out there for the pass module. Won't be a long one, but that'll be out there. And it will be like a lot like the practice one we did. And I'll also put out, like in a PDF or a doc, an example, a better example, how we convert this to a percent and so on. So that's that. And of course,
Mr. Ritchie,
yes.
so for the class practice for distributions, I didn't have some of the answers. So do you want us to just turn it in, or?
Well, I think we did them in, didn't we do them all in class?
I think we skipped some though, or maybe I missed that class and you haven't uploaded the Zoom yet.
I know
That's
I
what I was gonna ask because I wasn't here Monday and I went on there today, and the one from last Wednesday is there, but not the one from Monday. So I wanted to
Sorry.
ask you about that.
Yeah, Jalen, I'll get that uploaded.
I appreciate it.
So let me put that on my to-do list too. I also, so I need to upload I usually do that on the weekends, upload the Zoom. And that should fill that. And then do the example. Like more classwork when I say example. So we can work through that a little better, because I don't think I made it very clear. And then, what was the other thing? I've already forgotten. Oh, the test, last module test. And if I'll upload it, and if it doesn't have what you need, just send me a text and we'll get it fixed.
Okay, thank you.
All right. Well, thanks for coming, everybody. I really appreciate it. And I will see you Monday. And if you need me between now and then, please just send me a text and we'll take care of it.
Thank
Thank
you.
you.
Have a good day.
Okay,
Take care.
All right. You too. Bye.
Bye.